All right. Atosapo is better. Okay. So, celebrity, are you here? Okay, better. So let's proceed. WhatsApp is meant for discussion, like not using a board. It's meant for facial discussion, not using board for like teaching. That's why people use Zoom or any other app, but not WhatsApp. Okay. Okay, so let's proceed. I hope Faye be able to get these things done so that we can proceed. Faye, have you succeeded? All right, so while we wait for him, we are done with this aspect. We are going to be looking at another aspect, which is what? Inductance in an AC circuit. Inductance in an AC circuit. Let me sketch it here. All right. So now look at this. You can now see the diagram and tell me the difference between this and this. Who can tell me the difference between this diagram and the former one? You can now look at, now we no longer have resistance, we have an inductor. Okay, we have an inductor. Now this inductor stood in place of resistance in this circuit. Okay, so now everything about this will certainly going to do what? Change. It's going to change. How are we going to change? The former one we did before I cleaned the board, before we went back to YouTube. The last one I did, okay, before I now changed to YouTube. That one was resistance in an AC circuit. The first diagram has what? Resistance here. A symbol that's like this, which is a resistor. Okay. Now we have what? An inductor. Everything will change. And I told you the other one, which is the resistance and AC circuit, current and voltage are in minimum and zero value at the same time. Okay. But now in this one, what happens? You're going to see that they are not in the same phase, so they are out of phase. One is leading while the other one is what? Lagging. Okay. I will say note. Let me say voltage. If I say VL, that is voltage across what? Inductor. This current, okay, by 90 degrees or pi over 2. You can understand? Voltage leads current by 90 degrees of pi over 2. So I have something like this. So this is VL and this is what? IL. Right? Now, this is 90 degrees or pi over 2. You understand? So I can give you a graphical representation of voltage leading. You have a graph like this. Now this starts from 0. You know, this is 0. Why another one starts from here? You understand? So this one is voltage. This is voltage. Why this one is what? Current. Okay. Now voltage is at a value higher than that of what? Current. So that is why it is leading. Do you understand? That's why voltage what leads. You cannot compare voltage with current here, which is at 0. Do you understand? The start point is at 0. So this one is higher than this. That is why voltage is what leading. And this is the vector diagram. Please note. Vector diagram. They can give you a sketch of this in JAM and tell you to which one is correct for inductance in an AC circuit. Okay. So this is what the voltage is going up while current is going this way, right? So voltage leads what? Current. Don't forget. Now, if you know all this, you must remember that from Ohm's law, I've been making reference to Ohm's law because this is an electricity. So Ohm's law, V is equal to IR. Now, for the fact that this resistance is no longer in this circuit, we cannot continue to put resistance. You're going to name it another thing and with a different symbol. Do you understand? So now we are starting. And I told you before that this is everything that is going to be changing as we progress in different circuits. So I have VRMS is equal to IRS SL. It has changed. What is SL? SL is inductive reactance. Inductive reactance, right? Now, because it is an opposition to the flow of electric current offered by an inductor, it is still measured in what? Ohms. So it is measured in ohms. Do you understand? So how do we get this inductive reactance, which is SL? Now, for us to get it, SL is equal to 2 pi FL, right? And what is L? That is inductance of an inductor. Okay? Now measured in what? I will say measured in Henry. Denoted by capital H. I can copy. Let me explain myself better. I said that in this circuit, you no longer have resistance. We now have what? An inductor. Now, by this inductor, what happens? What is leading, what is lagging? Voltage leads what? Current. And current lags what? Voltage. Are we there? All right. So I can say that voltage is what? Leading. While current is lagging. And it is leading it by 90 degrees or pi over 2. I hope you understand. Now we are making respect to Ohm's law. From Ohm's law, V equals IR. What is R? The resistance. For the fact that the resistance is no longer in this particular circuit, you're not going to be making use of R. And I told you earlier that R is going to be changing from one circuit to the other. Do you understand? So now, what we are going to change it with? We are going to change it with what? SL. What is SL? Inductive reactance. Inductive reactance is an opposition offered by what? An inductor. And because it's an opposition, it is also measured in what? Ohms, right? Which is also the unit of resistance. So if I ask to calculate this inductive reactance, it is equal to 2 pi FL. What is L? Inductance of an inductor, which is also measured in Henry, H. Do you understand? And most times it is being kept in millihenry. You know what is milli? Milli means it can be kept in millihenry. That is, let me say 10 millihenry. You know what is milli? Milli is 10 power minus 3 Henry, right? Please note it. Do you understand? Now that is one question they might ask you from this. They might also ask you for what? VL. What is VL? VL is voltage across what? The inductor. Voltage across here. That is IS what? L. Do you understand? Alright. So look at it. These are the things you might note under this topic. Let me see if I can have a question from there. You have question? We have question, guys. If you don't have, let me bring up one question. Please, do you understand what you are saying? Do you understand? Please, do you understand? Comment. Let's know so I can proceed. A celebrity at Osakwe at Feyi. Alright, celebrity, do you understand? Alright, it's making sense small, okay? Let's look at questions. This topic is all about teaching small, solve questions. You will not have to teach all at the same time before you start solving, because you're going to get confused. Now, to explain inductance and AC circuits, I'm going to bring out a question under inductance and AC circuits. One thing you must know that JAMB will ask you, which one is leading, which one is lagging? I've told you. Voltage is leading, right? Now look at that vector diagram, very important. It's also in your pre 50. If we open it now, maybe page 120 as the case may be, you're going to see the question under that right now. So if I want to solve a question under it, let's see what we have. All right. Now you must know that resistance is no longer there. Using SL. What is SL? Inductive reactance. An inductive reactance is an opposition offered by an inductor and is measured in what? In ohms, because it still stands in place of what? Resistance. So what is SL? Is equals what? 2 pi F. Are we there? All right, guys. One question under this. Let's see. So the question, so that is question 2. At what frequency would a 10H inductor have a reactance of 2000 ohms, right? So let's look at the options provided. A is pi over 200 Hz. B is pi over 100 Hz. C is 100 over pi Hz. And D is 100 pi Hz. Now guys, look at this question. The question says, let's read it together. The question says, at what frequency would a 10 Henry inductor sorry, have a reactance of 2000 ohms? Now, what does that mean? What is reactance? That is what you ask yourself. You know what is reactance? That is inductive reactance. Because they did not say inductive reactance, you'll not be thinking that reactance is something different from what you already know. No. It also means what? Inductive reactance. Now, how can we answer this question? So, the reactance, which is the symbol is SL, is what they gave us to be 2000 ohms. And they expect us to find what? The frequency. And mind you, look at the answers. The answers are left in terms of pi. So that means pi should be kept as pi You should not convert or put the value of pi, which is 3.142. No. In most JAMB questions, they always leave the answer in terms of pi to avoid the confusion and because of time limited. Do you understand, guys? So you must look at the question and see if the value has pi. That means you're going to solve as though pi do not what exist, but replace the value of pi as what? Pi. Now let's go. For the question, the inductive reactance, sorry, my mark, I just filled it now. The inductive reactance SL is given as 2000 what? Ohms, right? Is given as 2000 ohms. And I asked to find the frequency. So the inductor of an inductance is what? 10 Henry. And you're looking for F. You must know something that relates between both of them. That SL is equals to 2 pi FL, right? Knowing fully well that this is equals to this, let's just put our multiplication and we go. What is my SL? It's given as 2000 is equals to 2 pi times F times what? 10. Are we there? So this is 2000 is equals to 20 pi F. Now, because we want to look for the value of F, we divide both sides by 20 pi. Remember, keep pi as what? Pi. Don't convert. This cancel. So my frequency is equals to, this is 2000 over 20 pi, right? So 0 cancels what? 0. 2 into itself 1, 2 into this is what? 1. So F is equals to 100 over pi what? Hz. Do you understand? Are we clear? Please guys, do you understand? Are we clear? Please respond. Let me know our state, whether you understand or not. Faye, are you here now? Okay, Atosakwe, do you understand? Faye, can you see the board? Do you understand, Faye? All right. So that is how to solve problem associated with what? With inductance. Now, looking at the first question, you're going to see a lot of questions that you need to solve under this one, right? So you can go ahead and practice it. Do you understand? Even the vector diagram I just drew is a question in your past question. So please go and note it somewhere. Do you understand, guys? Okay. So let me look at capacitance in an AC circuit. Okay? Capacitance. Capacitance in an AC circuit. Alright? So let's draw our diagram again. Alright. Look at it. The same diagram, but we no longer have what? Resistor. Last time we did was inductor. Now we no longer have what? Inductor. We have what? Capacitor. Capacitor. Please don't get this confused. When you have two parallel plates, it is called what? Capacitor. When you have a small and a shorter one, it is called a cell. Please don't get it confused. This is not a cell. This is what? A capacitor. Okay? Alright. So now, what you should know about this is that In this circuit, current is leading. I will say current, that is IC, leads what? Voltage, right? Is leading, right? And it leads it by 90 degrees of pi. Okay? Now, what is the vector diagram? Very important for JAMB. Vector diagram. Okay? So I have this, I have this. So this is what? IC and what? VC. So this is leading while this is lagging, and it's leading by 90 degrees of pi over 2. Are we clear? Now, the same way we replace resistance is what I'm going to use to replace this capacitance. Now, using from Ohm's law, V RMS is equal to I RMS what? Let me say S what? C, right? XC. Now, what is XC? XC is capacitive reactance, right? So XC is equal to 1 over 2 pi FC. Okay? FC is equal to 1 over 2 pi FC because they are inversely what? Proportional, right? Now, knowing this one is somehow different from what you did before. Somehow a little slightly different. The reason is because it has 1. Okay, please don't forget. Once you do not put 1, you will not get the correct answer. Is that clear? Alright. Is there another thing we need to talk about under this topic? Any other thing? Let me confirm if I go to the next one. Nothing much. We will ask to find the PD across VC. Okay, I will say potential difference. Okay. Now, what is potential difference? That is what? VC is equal to ISC. Is equal to ISC. What is I? Current, okay? Now, what is IX? What is XC? In capacitive what? Reactance. Capacitive reactance, guys. Capacitive reactance. Please, are we following? Faye, are you here? Are we following? Is it clear? All right. So let's solve one more question or two more, depending as the case may be, under this concept. Please, are you done writing? You can screenshot. Are you done writing? You can screenshot, okay? All right, it's clear. Okay, so let's go to an example. Okay, I will say that at what frequency would a capacitor of 2.5 microfarad used? Oh, okay, there's something I missed, but I'll just say before I start solving, please. In a radio circuit, have a reactance of 250 ohms. You have the following options. Option A, 800 over pi Hz. Option B, 200 pi Hz. Option C, 2000 pi. And option D, pi over 800 is. Okay. Now before we can think of solving this problem, there is something I forgot to tell you when I drew that diagram of capacitance and AC circuit. Please mind you and hold on so I cannot forget that the capacitance of a capacitor is measured in what? In microfarad. Okay? See how the symbol is? You just write you and put like this. This is microfarad, okay? Now this 1 microfarad is equal to 10 power what? Minus 6 farad, okay? Now because capacitor, capacitance of a capacitor cannot be kept like that without putting it in microfarad. Very, very important. So that unit is important. But when you want to solve for some other thing that is not capacitance, overall capacitance, okay, you're going to do what? Convert it, remove that micro by multiplying by 10 power minus 6. I hope that is clear. Is it clear? Is it clear, guys? All right. So let's proceed with the question on the board. The question says, at what frequency would a capacitor of 2.5 microfarad use in a radio? Are you there? Now, the same way you solved the previous one is what I'm going to use to solve the other one. All right? So let's see. So my frequency is what I am looking for. And my capacitance of the capacitor is 2.5 microfarad. And the reactance, which is XC, is given as ohms. Right? Now, guys, look at the magic. Let's go. We have what? SC is equal to what? 1 over 2 pi FC. Okay? And what are we going to do? We are given this. You have to find this, guys. So now the answer is in terms of pi. So you don't need to convert. Please, you must be conversant. You must be careful to look at the options of a particular question. That will give you a clue of how to go about with it. So what's my XC? I'll say 250 over 1 is equals to what? Equals to 1 over 2 pi times F times what? The capacitance, which is 2.5. You must remove that micro, right? And now just multiply 10 power minus 6. Is that clear? All right, so let's just break the calculation down the way you understand. This is 250 over 1. Okay, now it's equal to what? 2 times 2.5 is what? 5. So this is 1 over 5, right? Times pi times. Okay, now this is what? 2 times 2.5 is 5. Okay, that's why I have 5 here. Then look at power what? Minus 6. Now, because there's no calculator, you can actually do this and make it work. How? You can carry this minus 6 up because what? A positive 6, right? Which is 1 million. So let's go by that. It says that 250 over 1 is equals what? I'm just taking my time to solve it. This is not supposed to how you're going to do it on that day, but just learn it now and master it. So this is 250 pi times 10 power what? Minus 6. Carry this one to the other side. So I have what? Say cross multiply. 250 times what? 250 times this. No, this is sorry, this is 5. Sorry guys, this is 5, okay? That is 5. We have F pi. Alright, so I will say cross multiply. I will say F is equal to 1 over 250 times 5 pi times 10 power minus 6. Now 250 by 5 is going to give me 1,250, right? Carry this power minus 6 up, that is F is equal to 10 power 6 divided by 1250 pi. I don't know if I'm really making sense, am I? if you have that question like this, you're going to change this from microfarad. You now change it by multiplying by 10 power minus 6, okay? Then carry it up to the numerator. The negative 10 will change to positive, so you can be able to do your division and get your right answer in the option. Do you understand? So you're supposed to be fast, but then you're learning for the first time. So you're supposed to assimilate it and understand the pattern as which questions comes from this angle so that you make mistake. Okay, guys. So F is also equals to, this is 1,100,000, right? Divided by what? 1250 pi, right? By the time you keep dividing, by cancel this and this, 5 will go like that. You're going to end up having what? 800 over pi is. Do you understand? You're going to end up having what? 800 over pi what? Is. And that is how to solve that kind of question. Alright, guys. Do you have any questions so far? Any questions so far, guys? All right, so if there's no question, we're going to end the class here to continue tomorrow. But then from your pre 50, you have an assignment that I'm going to do. Work on it and get back to me on WhatsApp if you have any issue or challenge doing them. All right. From your pre 50, go to the topic AC circuit. Look at the content, go to AC circuit, okay? So you're going to, let me see a question that I have here under this. Okay, please go to number 16. That is assignment number 16. Let me check again. Number 19. Number 20. I'm looking at the one that have the one you have done so far. So it will be easy for you to solve. Number 27. So I have these 5 questions I can comfortably solve with what we have done so far. Okay, so I'd like you to work on this on pre 50. Go to the content, look for simple AC circuits. On there, you're going to see this numbers of questions of what we have done. So I want you to look at it and solve it and give me the answer in the comment section or drop the answer in the WhatsApp group. Are we cleared? Any other question? All right, so in the absence of no question, guys, we're going to stop here to continue tomorrow. So don't forget to drop in your questions, observation, anyone you feel like correction. We are just trying to make sure that you can comfortably score high in the exam without cheating on malpractice. Okay? All right, guys. Okay. So please, you can screenshot to get the assignment on the pre 50. All right. So we are going to stop here for today. See you tomorrow. Bye. Please, I'm expecting your questions on WhatsApp. Celebrity, are you still with us? You heard what I said? Apostle, you heard what I said? All right, guys. Bye.